Poisson regression using SPSS. In this video, I have used factors affecting number of physician visits by patients, which is count variable. First, analyze, then generalized linear models, and click on generalized linear models. Type of model. Select the type of model as Poisson log linear. Then click response and move dependent variable, which is medical doctor visits per year, into dependent variable box. Then click predictors and move all categorical independent variables into factors box. And move continuous independent variables into covariance box. Then click model and select all independent variables and move them into model box. Then estimation. Of course, you can skip estimation. Then statistics. Here, select include exponential parameter estimates, which shows incidence rate ratio for each independent variable. Then finally click OK. From SPSS output, we get continuous variable information. For dependent variable, which is medical doctor visits per year, the mean value is 3.16 and standard deviation is 6.276. Here, when we square standard deviation, we get a variance of at least 36, which is much greater than the mean. So we can infer that there is over-dispersion in the data. In this case, we have to consider alternative models like negative binomial models. From goodness of fit, we get deviance value divided by degrees of freedom of 6.186 and Pearson chi-square value divided by degrees of freedom of 11.355. So these values are far away from 1. Therefore, the model is not good. Here, a significant p-value of log likelihood chi-square shows that the model with independent variables is better than the null model. Here, tests of model effects show that all independent variables have statistically significant effect on dependent variable. And finally, parameter estimates. Here we get exponent of B, which is incidence rate ratio, and all independent variables have statistically significant association with dependent variable. Moreover, 95% confidence intervals are narrow, which indicate a high power of study and less conservative nature of Poisson model.